A hydraulic design project requires a certain amount of prerequisite data for rainfall definition, storm events, and various other types of design information. The repository of this information is a hydraulic seed file, and this is normally going to be stored as a DGN library. This video will be an introduction to the hydraulic seed file and give a high-level overview of the different workspace elements that will need to be configured. The hydraulic seed file is not to be confused with a seed file. Seed files are used during the file creation process, and their purpose is to standardize all new designs so that every newly created file will have the same working units, color table, and views as those have been set up inside of the seed file. A hydraulic seed file, however, copies hydraulic information into the DGN after the file has already been created, and this is going to happen as soon as you launch any of the drainage and utilities tools. So now let's take a look at some of the common properties that you're going to be storing inside of your hydraulic seed file. And I'm going to start on the Tools tab under Options, and this is where you can set the options for the drainage database or the utilities database. And within here, you'll set miscellaneous settings pertaining to the model. It's going to be things like how often is the model going to be compacted, element labeling options. You can control where the result files are going to be stored. You can also set the units, so we can control what units are used and how the values are going to be reported. I'm going to move over next to my Components tab, and we'll start with the storm data. So we'll want to set up storm data. You'll need to include IDF tables that will be used for the rational method. You'll also want to include time-dependent data that's going to be used when you're running an unsteady state analysis. Over here we have the catalogs. So the inlet, gutter, and conduit catalog are all going to store physical properties of the inlets, gutters, and conduits, and then those can then be referenced by the features. Then we have some other different types of catalogs that we can use, like culvert inlet coefficients or land cover, and then there's some miscellaneous libraries here. The hydraulic prototypes are going to be set, we're going to have one for each hydraulically different feature. So those are going to act as the default hydraulic settings for each one of those different features. Moving over to the Analysis tab, I'm going to start with the default design constraints. And here you're going to set the design constraints for gravity pipes, nodes, and inlets. So this is going to act as the project defaults when you first start the file, and then they can be overridden as needed per project. Next I'm going to talk about alternatives, options, and scenarios. So I'll get all three of those up on my screen. And then I have some properties over here on the right. So if I take a look at the scenarios, you can think of a scenario as a container for a set of alternatives and a calculation option. The alternatives are categorized groups of element properties that create scenarios once they've been grouped together. And then the calculation options are going to contain attributes that define how the model is calculated in the software. And then once these are combined together to form a scenario, your scenario is going to be your what-if situations for the model. And from there you can modify, compute, and review your system over those different types of conditions.